Yeah, I begin with a coordinate, and then use the coordinates. How do we do the calculation, like the area of triangles and and the area of the circles, for example. Okay. Okay. So in my basic class, already talk about coordinate line and the coordinate system in the plane, right? So coordinate line is just a line and with the units, okay? So once you choose a point called origin, and then a point, then you mark, okay, this is a distance of 1 between those 2 points. Then every point on the line corresponding to numbers. So there is a correspondence between the points and the numbers. Okay? There's when those numbers called coordinate of the point. Then this is one-dimensional, right? And two-dimensional, we have it's a perpendicular, right? We have a two coordinate line corresponds to each other. Then every point is a plane, okay? Of course, you have to use the coordinates here, 1, 2, 3, right? And the units, okay? 1, 2, 3, 1, 2, 3, 4. Then every point, okay, corresponds to a pair of numbers. And here, every point corresponds to one numbers, right? A point P, and then there's a number corresponding to that. They call it A is called the coordinate of the point P. Okay? Yeah, a number corresponding to the point P is called the coordinate of the point P. Now this is a P in the plane. Once you choose the two coordinate line perpendicular to each other, then you can use the two numbers to describe this point. Okay, so draw the vertical line perpendicular to the horizontal line, right? And then that point, if the coordinate at that point is A, then you draw another horizontal line. This vertical line, yeah, then draw a horizontal line, you get the intersection point. This intersection point, if the coordinate of the intersection point is B, then use the A and the B, we can describe the location of the point. So here we still have the points corresponding to a pair of numbers, okay? Order the pair of numbers. Okay, so there is correspondence. So use that, on the right hand side is algebra, on the left hand side is geometry. So coordinate geometry means we're going to use algebra to study geometry, okay? And you can go one more dimension high and three-dimensional space. How do you do that three-dimensional space? Then it's hard to draw it. It's a 3, right? Coordinate line 1, another coordinate line, and then another coordinate line. So all perpendicular, okay, to each other. Okay. Then it's hard to imagine the space. So those coordinate lines has units 1, 2, 3, right? 1, 2, 3, right? Here's another 1, 2, 3, 4. Those are the numbers on the line, right? And then you also have a 1, 2, 3, right? So a point in the space, okay? You can describe it by 3 numbers, not just 2, because it's a space, a 3-dimensional space. You need three numbers to describe. Okay, how do you do that? You draw the line perpendicular parallel to this vertical line, and then you get a point in the plane. Then you draw the 2 lines here. Okay, if this number is A, that number is B, and this number is C, then you have 3 numbers to describe this location of this point. Okay, so those are the then a point in the space 1-to-1 correspond to the ordered triples of numbers. Okay, so the point can describe it using by the ordered triples of numbers. Okay, so that's a coordinate system. Now let's try to solve some problems. Okay, the first problem I want to discuss is a triangle. Okay, has vertices with coordinates -2, 4, 0, 0, and 4 and 2. Okay? We want to find out the area. What is the area of the triangle? Okay. Now, the triangle is not given. Okay, how do you find the area of a triangle? We have to find the length of the base and the height, right? But we cannot use that formula to solve the problem. So let me put the triangle here. So -2, okay. -2 and the 4 is here. 1, 2, 1, 2, 3, 4, -2 and 4. This is the point is here, right? And then 0, 0 is here. And the 4 and the 2, 1, 2, 3, 4, and the 1, 2, yeah, here's another point. Right? So you should know how to plot the point if we are given the coordinates. All right, now what I'm going to do, we connect them, right? So you get a triangle. All right, you get a triangle. So the question is, how do you find the area of this triangle? Think about that. Well, a typical formula for the triangle's area is going to be the base, half of the base times height, right? Yeah. Area is going to be half of the base times height if you have height and the b. Right. Right. So that's my hint, right? But that's not useful. I just tell you, this formula is not useful. But cannot use the formula directly to solve a problem because you don't know the height, you don't know the base. It's impossible. It's almost, yeah, it's very difficult to find height. Any ideas? Okay. Nansen Zhang, yeah, give me some ideas. Yeah, you use right triangles. Okay, there's no right triangles, but you can draw triangles like that. Okay. Yeah. Sometimes you can even draw more triangles, but that's good enough. You can get a trapezoid, okay, and trying to find the area of trapezoid, then subtract the area of the two triangles under this yellow triangle. Okay, so all you have to do is to make sure what is the height. So this is going to be 4, right? This is a 2. Here's a 2, and that is a 4. Okay, so we know the area of trapezoid. If you don't know the area of trapezoid, you make another triangle, so you get a rectangle. Okay, you can get a rectangle. This is a 2. From here to here, -2 to 4, it's a 6 actually. Okay, let's use this one. So the area of the triangle is going to be the area of the rectangle. Rectangle is a 4. I'm sorry for that. It's gone. Okay, back. I'm looking for somewhere. I'll touch it. Okay. So, yeah, this is 6. This is 2. Okay. So the area of the triangle is going to area of the rectangle is going to be 4 times 6 minus the area of the 3 right triangle. Right triangle is half of the base, the one on the top, and then the one on the lower right is going to 4 times 2, and the one on the lower left. Okay, so let's simplify. 24, 6, and -4, -4. Okay, so it's going to be, yeah, 14, -14, right? -14, so it's going to be 10. Yes, so 10 is the answer. So that is the way how do we solve the problem. Now can you find the base times the height? You can, but it's the base and the height both are not a rational number. They're both. If this side is A, this side is B, this side is C, you can find A, B, C. Okay, right? And then using the so-called distance formula. Do we know the distance formula? Yeah. If I have a about distance, you need to know the distance formula. You know to find the edge length of the triangle. So the distance formula, we call the distance formula. If it's just coordinate line, if here's A, that's a B, and the distance between those two, this point is a point called P, and was coordinates A. This point Q is coordinates B. So the distance between P and the Q is just the difference of these two variables, two coordinates, and you take up a absolute value. The distance is always positive, okay? Right? But now, for 2 points in the plane, okay, if here's a point, that's called A1, B1. That's another point. This is a P1, right? And the P2 and A2, B2, those are coordinates. And in order to get to the distance between P1 and P2, you have to draw the right triangle. And then use a Pythagorean theory. You solve the problem. Here's B2 here's A2 minus A1. This side is B2 minus B1. So then by the Pythagorean theory, the distance between P1 and P2 is the square root of the square of each side. So it's A2 minus A1 square, B2 minus B1 square. All right, then you can find the edge length if you want. Okay, but they're complicated. The edge length is complicated. Irrational numbers. Okay, maybe right. Let's try the game. Here's a 4 and 2, -2 and the 4, and the z and the 0. Let's find the A, B, C. Let's find out what the A, B, C. Right. A, the square root of the difference of the two coordinates. Okay, it's going to be 16 plus 4. It's a square root of 20. Square root of 20 is going to be 4 times 5, so it's 2 square root of 5. That is a number. It's an irrational number. Okay. And similarly, you can find the B. They're all irrational numbers. But the area is a fraction. Okay. So using the three sides, how do you find the area? Do you remember the area formula? Well, if you don't remember, if you remember the three, if you know the value of the three sides, if you know the three sides, you still can find the area. Okay. But that's the formula. Yeah, we will discuss later in chapter. Yeah, few chapters later about area. So I'm not going to spend too much time on this. Okay, this is a distance formula. The distance formula follows from the Pythagorean theory. Okay, we're going to discuss more about the Pythagorean theory later. So what I want you to do in the class today is the following. Given the triangle was a three-component, with three coordinate lines. Given triangle was a three vertices. So let me draw the triangle. Actually, this passes through the origin. Okay, so let's. The first coordinate -2, +1. Second coordinate 1 and 3, and here is a 4 and -2. Find the area. Okay, please work on this problem. Now you just learn how to find the area of triangle. You do not focus on the triangle directly. You focus on the right triangle surrounding the triangle, and you solve the problem. Well, any answers? Right? This is a 2, right? It's 2 common plus 1. So what you do is you use a rectangle and draw the rectangle, right? Draw the rectangle. Then you have the area of the rectangle, then minus area of small 3 right triangle, then you solve the problem. Okay. Right? Can you figure out the edge length? So William says 13. Anyone has different answers? Okay. Somebody give me 9. Nelson. You got different answers. Okay. Well, you got a different ideas. Okay, be careful when you figure out the edge length of the rectangle, which which contains the triangle. Okay. So I get 3 different answers. So this is not a difficult problem. Just be careful. Everybody should work on that. Okay. So we can move on to next class. So 2 of them must be wrong, right? If you have 3 different answers. Someone gave me 9, 13, 13.5. Okay. Maybe someone should give me the different answer, the 4th different answer. Okay, Alex, any ideas? Your name is always on the top. Right. William. Okay, finally give me different answers. Okay, let's try. Let's try, okay, to see. Let's figure out the edge length, right? This side from -2 to 3, right? So just look at the second component. So from -2 to 3 is 5. Okay, this one from -2 to +4, that's be 6. Okay, that's a change in the x coordinate, right? And here from -2 to -2 to 1 is 3. From 1 to 3 is gonna be 2. So total is 5. 3 plus 2 is 5. Okay, and here from -2 to 1 is 3. From 1 to 4 is also 3. So total is 6. So this is a rectangle, 6 by 5 rectangle. Right? Then using that, you can quickly solve the problem. Ah, Nathan, so wait, you messed up. That's a computation mistakes. Okay. Finally, someone give me a correct answer. Now, you should be confident in this, okay? Okay, so the area of the triangle is going to be the area of the rectangle, which is 6 times 5, minus the area of the, let's say, the upper right, right? Half, right? 3 times 5. Then the upper left. Then the up, actually lower left, right? Okay, so let's see. 30, 15 over 2 minus 3 minus 9. Okay. Okay, so this is first of all, yeah, let's figure it out. It's 10.5. Yeah, 10.5 should be correct answer. Okay. Oh, it's difficult, not difficult, right? Just draw the picture, just like a puzzle, you know, and just figure out how many pieces, what is the age length on this. All right, let's try another problem. All right, so we know that the 4 vertices of a square, so we are given a square already. Given square A, B, C, D, have coordinates -4, 2, 1 and 14, and 13, 9, and 8, -3. Right, find the area of the square. So we are given 4 points. You have to draw the 4 points, okay? Yeah, you draw the 4 points. So the first coordinates is not -14, it's -4, okay? So you draw this, okay. -4 and 2, okay? And 1 and 14. Yeah, this is probably the triangle. 1 and 14 and 13 and 9 and 8, -3, -4 and 2. Can you find the area? Think about it. Yeah, you already told that it's a square. Okay, if you're not, you have to prove it's a square. Right? It's not easy to prove it's a square. So you're told that it's a square. You double check it's a square and find the area of the square. You just need to find the what? right? Oh, there were so many different answers. Okay. Right. All right. So Nelson. So the point is you have to find the edge length. If you're told that this is square, then just need to find the one edge length, right? You use a area formula, the distance formula. Distance formula is it's going to be distance of two x coordinates, 13 minus 8, and then 9 minus negative 3 squared, right? Yeah. So you will get the 13 minus, it's a 5 square, and this is going to be 12 square. Now this will be square root of 169, so which is 13. So 13 squared 169. So the area is just a square, so 13 square. Okay, that's it. Okay, you don't need it because you already told that it's a square. Okay, you don't need it to find more than that. Just look at the one edge. But of course, if you suspect this is not square, you have data about that. Then you can double check. Maybe how do you prove this is the right triangle? A right angle, right? At the angle, square by definition. It must be the right angle. If we just find out all the edge lengths are equal to 13, it does not prove it's a square. There are other pictures. It's not a square, like a parallelogram. So you have to, in order to prove it's a square, you have to prove this is right angle here. Okay. Question is how to prove that. All right, so this is about coordinates of the points and how to use them to calculate the area. Now for a curve in the xy plane, we can describe by equation. Okay, if x and y those are the coordinates and arbitrary point, if you this curve can be described by a relationship between x and y. Okay, so this is a curve. We were talking about point that corresponds to coordinate, and the curve corresponds to an equation we called equation that describe the relationship between x and y. Okay, and we know that this is important fact, lines correspond to linear equation. Okay, I'm going to show to you why. And the circles corresponding to the quadratic equation, right? So usually lines, have lines, the equation would be like ax, y equals mx plus b, okay? And the circles, right? And depends on where you choose the center. Change the origin. The center is fixed once the circle is given, because this will be the center. But the origin can be here. Okay? And then its corresponding equation, x minus x squared, y minus k squared equals radius squared. Right? We will talk about this later. Let's focus on the lines and the linear equations. Right? So for a line, given a line, how do you describe it? First of all, you choose the coordinate system. Okay. Then an arbitrary point, x and y, right? You can also choose another point, x1, y1. And you were very surprised the ratio of all this triangle. When you move this point up, down, okay, you get a similar triangles. Okay, so the ratio will not be changed. So the ratio here, this will be x1 minus x, right? This will be y1 minus y, the difference, okay? So this ratio remains unchanged. So y, I can switch the order, right? Y minus y1 over x minus x1, okay? This is the same as y1 minus y, x1 minus x, right? And this ratio is going to be a constant. And this constant is called the slope. Okay. So if that's denoted by m usually, then what do you get? You get y minus y1 over x minus x1 equals m, and then y minus y1 equals m, x minus x1. So this is a linear equation you get for the line. Okay, that tells you how x and y are related. Okay. All right, so let's take a look at let's take a look at the following problem. Okay. A line passes through 2 points. Okay. Let's find an equation for the line. All right, so what does that mean? Let's draw the picture first. Okay, you have a point, 2 points. 1 and 2. Another one is negative 1 and 4. So these 2 points, its coordinates and we're trying to find the equation. Right. Somebody did pretty fast. All right, so first of all, let's try to figure it out. Right. What is a slope, right? We said that the ratio of these two sides of a triangle gives you the number which is called the slope. It would be independent choice of the 2 points on the line, right? So this ratio that's going to be slope is the difference of the difference of 2 y coordinates over the difference of 2 x coordinates. Right? If you have this could be called x1, y1. This is called x2, y2. Okay, let's write down the slope first. The difference y2 minus y1, 4 minus 2, x2 minus 1, x1. So it would be 2 over -2 will be -1. Okay, that is a slope. It doesn't matter where you choose a pair of points. So let's take an arbitrary point x and y, right? What's coordinates x and y. Right, then I use this pair, I should get the same slope. So that means the slope is also going to be y minus 2 and x minus 1. Okay, so that gives you the relationship between x and y because the slope is already given. So the equation is going to be this. All right, great. So we're almost done. So we write this, and you get multiply both sides by x minus y. So this is a linear equation. Okay, this is we call the point the slope form. The slope is there, point is there. It's called point slope. But if you rewrite it, again you will get -x plus 3. Okay, this is another version of the equation, but the coefficient in front of x will be the slope always. Right? So now what do we got, right? We use an equation to describe the line. Okay, let me go over again. So we're given a line. So we're given 2 points in the xy plane. We're given a line passing through those 2 points. To find the equation means we are going to find the relationship between x and y. An arbitrary point, or an arbitrary point on the line. So first I don't consider arbitrary point, I consider the 2 specific points. And use the 2 specific points, I find the slope. Then I find the slope using this arbitrary point on the line. And then I get y2 minus over x minus y. And that should be, the ratio should be slope. So slope already know that, -1. Then you get a relation between y and x. Right? Right, great. So we got the equation. I'm going to ask you to do the problem right now. Right. So from the equation, you can tell some information here. Okay. So so let me summarize it. You have 2 points as coordinates x1, y1, p2, x2, y2. Then the slope is going to be y2 minus y1, f of x2 minus x1. And then the equation, you can use any of the points. That would be m x minus x1. Right? Right. So this is how to. And conversely, if you can write in this form, this is in front of x is always the slope of the line. Okay. So I'm going to ask you to do the following problem. Okay. Given 2 points, right, with coordinates -5 and 3, 3 and 2. Okay. 3 and 3, let's use 3 and 3. Okay. Find an equation of the line, right, passing through these 2 points. Please go ahead and do it. Hello, anyone have answers? Just give me the equation in the form like a y equals mx plus b. Find the relationship between, find the relation between x and y. Harry, William Ma. First of all, use the 2 points to find the slope, right? Right? You sketch it out, right? -1 to 5 is here, somewhere here. -1 to 5 is here. 3 is here. Right? And this is a line, right? Passing through here. Right? Step 1, you have to find the slope. Slope is the difference of a y coordinates. Doesn't matter which one is first. The left one is first. And 5 minus 3. Then over the difference of x coordinates, -1 minus 3. So that'll be 2, -4 will be -1/2. All right, anyone have a so slope is -1/2, right? So for the equation, you just choose any one known point. Y minus 3 equals the slope times x minus 3, right? You can use that point. And after you finish it, you get the same answer. Okay, we can check that, right? y minus 3 equals negative 1/2 x plus 3 over 2. So y equals negative 1/2 of x plus 3 over 2 plus 3. I think it's going to be 9 over 2 here, not 5. Right? Now you can use another point, negative 5 and 4. So y minus 5 equals negative 1/2 x minus negative 1 and negative 1 and 5. Yeah. So, right? Then we simplify, we should get same version, same equation. Minus 1/2. Okay. So now you will get negative 1/2 x plus 5 minus 1/2. 5 minus 1/2 is going to be 9 over 2. And we get exactly the same answer. Yeah, so the meaning of the, let's go back to, let's understand the meaning of the slope. So here's the point, right? x1, y1, x2, y2. So you have the difference, delta y is delta x. That could be negative, could be positive. In this case, it's positive. y2 minus y1, and here's x2 minus x1. So slope is the ratio of these two number differences. Okay, so delta x is x2 minus x1. So it's positive means you go to the right by delta x steps. And delta y is y2 minus y1. So if it's positive, delta y is positive means you move from that point up by delta y units. Okay, so you can, so how do you get to the y coordinates? Just y2, right? y2 coordinates delta y plus y1. So you just add the, yeah, y2 will be delta y plus y1. Just add a small change to the y variable of the first point, okay? And x2 is going to be delta x plus x. So let's see. Okay, but for a slope, you can, yeah, here's the question. Given the slope, m equals negative 3 over 2, and a point, p, the coordinates 3 and 1, okay? Using the given information, find 2 as a point other than the given one. Right. Other than, okay, on the line. Now the question, how do you do this? There's so many points on the line, right? We know this is a point P, and the slope is negative. Looks like that. Then I just want to find a bunch of couple points on the line. What is the best way to do? What is the best way to do? Okay, I don't need to go through the equation to find this, find a couple points. What I'm going to do is that m is going to be like delta y over delta x. So this is my starting point. Right, so delta y, so now we know it's negative 3 over 2. So I can express in two different ways. For example, this could be negative 3 over 2, right? This could be 3 over negative 2. So the first case is delta y equals negative 3, delta x equals 2. right? So that means delta y is -3 means we are going to go down by 3 steps. Okay, so here's 3 and 1. So the next point is the next point we're going to use to calculate the slope, right? So delta x is +2 means you have to go to the right by 2 steps. Here, 1, 1, 1, 2, right? Then -3 have to go down by 3 steps. Okay, this is another point. So 3 plus 2, 1 minus 3. So which is going to be 5 and -2. So this is another point on the line. So we already can draw the picture here because it's already there's a 2 points uniquely determined line, right? Now, if you use a second expression for the slope, so delta y is going to be 3, delta x is going to be -2. Then you will get another point on the line, but it's in the other direction. Right. So that means there's another point. How to get another point? X should go to the left. Yeah, you have to go to the left by 2 units. And then go up by 3 units. 1, 2, 3. So this should be another point. Okay, the coordinates of the point is going to be 3 is -2, and 3 is +3. So it's going to be 1 and 9. Okay, so this is just 2 arbitrary 2 points on the line. If you use a slope directly, you can find it. But you can find the general equation, then you can get infinite solutions. Right. All right. So my next question is, what is the slope of the line 2x plus 4y equals -5? Yeah, please think about this problem. Hello. Yeah, what is slope? Sonali, right? Sonali said -1/2. Good job. -1/2 is the correct answer. You just rewrite the expression, okay? 4y equals -2x minus 5, right? That should be -5. Yeah, be careful. It's -5. All right. Then you divide both sides by 4. It's -1/2 x minus 5 over 4. Okay. And compare with the equation. This will be the slope. The coefficient of x will be the slope. Okay, so the slope is going to be -1/2. All right. So slope, if the two lines are parallel, so this line has a L1, L2, and the slope M1, M2. Okay. So L1, L2 are parallel if and only if the slope are equal. You know why? Well, the slope, that means really the angle here is determined by the angle. Okay. This side over that side it really measures the size of the angle, theta actually. Okay. So if that pair means they have the same angle, then the ratio should be the same. Okay, this side over that side, this gives you slope. It should be same. So it's easy to understand. Okay, it's easy to understand if the two lines are parallel I know I cannot cover all the material, right? But I do have a as an exercise in the chapter, I'm going to send it to you. So when you do the homework, you find out, I don't know how to determine two lines are perpendicular, then you go back to look at the problems, okay? So what I want to do today, just one problem, okay? If the line negative x plus 5y equals -1 is perpendicular to, I'm going to change to parallel, okay? Yeah, because perpendicular would be a different formula. Is parallel to the line 5x plus ky equals -2. So we want to know what is the value of the k. We're trying to make the value, right? So all I have to do is just make sure they have the same slope. They have the same slope. So the first line, let's look at the first line. Right, we figure the slope, right? 5y equals, and the y equals 1/5 of x minus 1/5. And the second line, 5x plus ky equals -2. So ky equals -5x minus 2. So y equals -5 over kx minus 2 over k. So that parallel means this slope should be equal to that slope. Okay, so 1/2, 1/5 equals 5 over k. Okay, so k equals -5 squared, which is -25. So that is the value of the k. Okay, that is the value of the k. Okay, so so when the k changes, right, the first line is fixed. The first line is fixed, and negative slope, yeah, it looks like that. Okay, this line y equals. Okay, the other line has a slope of -5 over k, but when k changes, the slope, the all changes, even the y-intercept is changed. Okay, so you have a bunch of curves like that, a bunch of lines. But when you make a slightly justify the value of a k so that -5 over k becomes 1/5, right? Then you get the two lines, two parallel lines, as long as they have the same slope. So you need to start set up and get another equation, and then solve for value of k. All right, so yeah, -5, -25 is answer. Good job. I'm not able to cover all of them because trying to give you time to think about the problems. Right. So in the notes I'm sending to you, have more examples. You should learn. You should started to study by self-study. Self-study, improve the self-study skill. It's very important. So you look at my examples, and the other example I haven't discussed in the class yet, and then when you try to finish the homework, it's 15 problems each time. And then, yeah, we can move on to other topic of geometry. Okay. Yeah, let's stop here and have a good weekend. I think yes, class starts very soon. Yeah, your school will start, right?